information from our navigators, all this subsystem information, and they put it all together to package up what we send to the spacecraft so it can go about its business and give us back what we want.
So when you look back on your involvement with the mission, what have been some of the challenges that really stand out to you?
Oh, yeah, so many challenges, but like one I would say in particular is the tag arm itself. So we had to have a way to land without landing an unknown environment. We didn't want to get caught trying to figure out how to land and then take off again. So this innovative technology that Lockheed developed, it's called the tag arm. And maybe if you've seen the graphics of it already, you have the asteroid and the tag arm comes up to it and it blows some gas and collects that in the sample. So we have testing that, designing that. How do you test it on the ground? We came up with innovative ways to use the airplanes the astronauts use to check that into low gravity.
That's right. So you'd have to actually test it in a microgravity environment because that's what the asteroid's going to be like.
That's right.
Well, thank you so much for talking to me. I'm really enjoying that. The next thing that we're going to be doing is we're going to be talking to the project manager. And here is Rich Burns, the project manager at NASA's Goddard Space Flight Center. So thank you for joining me today.
Thanks for having me, Michelle.
I'm going to hand you my microphone.
Very good. Thank you.
So, Rich, maybe we could begin with sort of talking about the role of a project manager.
Project manager is basically a person responsible for keeping the train on the tracks, foreseeing problems, making sure that resources are allocated to identify areas where we foresee risk.
And I think so the train on the tracks, so you're the person that's sort of in charge of making sure one thing leads to the next?
Yes, of course, and that job's really quite simple in this instance because we have such a wonderful team with all our partners are very highly capable, so it's a joy to be managing them.
It's an exciting day for you here, I imagine.
Absolutely. Arrival at Bennu is one of the key milestones in this mission, and we've been awaiting it for a very long time.
So just to remind you, you can actually take some questions live now. You can use the hashtag AskNASA, or if you're on Facebook, just put them in the comments and we'll get to as many questions as we can. So we're going to start with a question from David Watts from F22 Tech asks, what is the process involved in getting the spacecraft exactly to where it needs to be today and not shooting past Bennu?
It's a great question, David. In fact, in October, we were, in September actually, we were hurtling towards the asteroid, and in October we executed a series of maneuvers to slow ourselves down. We call them the asteroid approach maneuvers, and they reduced the spacecraft speed relative to Bennu by over 1,000 miles per hour. These were large maneuvers we did with our main engines, and they're the last use of our main engines we'll have until we depart the asteroid. So everything from now on will be very small maneuvers to change our trajectory relative to the asteroid in very precise ways.
It really is incredible. This object is so small, and yet we're actually able to go into orbit around it.
I apologize for the audio problems. Those are on the NASA side.
Yes, and it's very challenging as well. The low gravity environment of Bennu is one of the foremost challenges associated with conducting this mission. Our navigation team is up to the challenge, and it has required some very detailed modeling of very small forces on the spacecraft. For example, the thermal emissions from the spacecraft as we rotate and change our orientation relative to the sun. The spacecraft will emit thermal energy that will change our trajectory very slightly, but that's important in this case.
Actually, that even leads into the next question. So the idea that the emission changes the trajectory very slightly is called the Yarkovsky effect. And we actually have a question. So it's Lou Cipriano asks, will the eventual tag operation to collect the regolith material after Bennu's orbit, given the minute forces at play in the Yarkovsky effect, it seems reasonable that the tag operation could have enough force to alter the orbit of the asteroid? Well, what would you say to that?
That's a great question, Lou. But our tag site is going to be so small relative to the overall size of the asteroid that we will not change the net effect of the Yarkovsky effect.
And as a reminder, CosmoQuest is going to be part of finding that rock that they bring back. So stay tuned for your opportunity to help find that rock. We should be getting the mosaic images soon.
While the asteroid is in daylight, and as parts of the asteroid rotate into nighttime, they emit thermal energy, and it acts like a small propulsive force on the asteroid. As the asteroid rotates through night, it gets cooler, and that force gets smaller, and that's sort of asymmetry is the Yarkovsky effect, and it changes the orbit of Bennu over very long periods of time. Of course, it's a very minute force.
When you think about OSIRIS-REx, it actually is an acronym. It's the origins, spectral interpretation, resource identification, security, regolith explorer. And so this is the security aspect of it. Is that right?
That's exactly right. As I mentioned, it changes the trajectory of the asteroid over very long periods of time. Bennu is a potentially hazardous asteroid. There's a very small chance that it will impact Earth in the next century. And the Yarkovsky effect is key in being able to predict Bennu's trajectory over that long span of time.
So we have another question. All right. So, Catalian on Twitter asks, is this the first time a probe has been able to send a sample back to Earth from another body?
Well, not exactly, but this is NASA's first asteroid sample return missions. Other probes have brought back samples. For example, Stardust brought back a sample of cometary dust. The Hayabusa mission from Japan brought back a small sample from its asteroid, but ours will be by far the largest sample collection from a robotic spacecraft.
I remember that you were telling me this was actually going to be the largest sample, but possibly up to 2 kilograms since the Apollo astronauts brought back moon rocks.
That's correct. It's very exciting. Yes.
Right.
And our science team is very eager to study this material that we'll get back from Bennu, which is thought to be the building blocks of the solar system. This is material that's been around since the birth of the solar system.
That's the origins part.
That's exactly
as the science goes. That's so exciting. Well, thank you so much for joining us. I really appreciate it.
Thanks, Michelle.
We are now, I'm going to grab the microphone from you there. We are now actually at 10 o'clock, which means that the orbit burn should really have happened somewhere out there in space. And of course, it's going to take the light about 7 minutes to actually get to us here. So this is, of course, a wonderful time. What we're going to do is we're going to go around and talk to some of the engineers that are involved in this process. And the first thing we're going to do is talk to somebody who actually does navigation. So once again, let me remind you that what you're doing right now is we are actually live at Lockheed Martin here in Littleton, Colorado, and we are about to arrive at the asteroid Bennu with NASA's OSIRIS-REx mission. We're going to have another chance to answer questions later on in the program, so if you have any questions, use the hashtag AskNASA. Or if you're joining us on Facebook, please leave your questions in the comments and we'll get to as many of them as we can.
I'd just like to point out that there is some amazing soul who's doing all of this backwards, keeping her centered and not walking into things, which means there's someone else guiding him. So there's now a whole herd of people walking around to talk about navigation.
Be here with you today.
Great to have you.
This is an exciting time for you?
Yeah, really exciting. The burn just happened on the spacecraft, and we're waiting for the signal to come back in a few minutes here.
So tell me a bit about your job as a navigation engineer.
So I work on the optical navigation component of the navigation system. So to navigate to Bennu, we have to determine the trajectory of the spacecraft that is flying currently. We plan its future trajectories, and we design the maneuvers to get us on those trajectories. And in order to determine where the spacecraft is, we use 2 types of information. We use the optical images that the spacecraft takes of the asteroid, and then we also use the signal from the spacecraft in the communication link when it transmits things down to Earth.
So when you talk about optical communications, optical navigation, there's no GPS in space. It's very hard to tell exactly where you are. You actually use the background stars to navigate and tell you exactly where the spacecraft is. Is that right?
Yeah, we use the background stars as the reference frame to tell us where the spacecraft was pointed when it took the picture. And then we can use where we observe Bennu in the picture relative to that to figure out where the spacecraft was relative to Bennu when it was taken.
So can you tell me a bit about what you're looking at here on your screen?
Yeah, so this is the trajectory that we're about to fly. So we just are doing M1P, the first maneuver of our preliminary survey mission phase, where we're about to do our first close flyby of Bennu, less than 5 miles, which will be tomorrow, 24 hours from now. And so we are going to do that 3 times. We're going to go over the North Pole 3 times, and then we're going to fly over the equator and the South Pole. And that allows us to not only estimate the gravity, the mass of Bennu for the first time, which will help us design our future orbits downstream, but it also allows us to map the whole surface and build landmarks that we're going to use to navigate once we get into orbit.
It's sort of amazing. So you're actually going from using things like stars and signals from the spacecraft to navigate to knowing Bennu well enough that you can actually sort of navigate by local landmarks.
Right, absolutely. Yeah, we're building these maps, and that will give us the precision that we need to continue on to higher mapping phases and lower orbits. It will really be record-breaking in terms of the precision navigation that we've done in space before.
It's an exciting moment. How are you feeling?
I'm nervous and excited.
Have you done this before? Is this sort of the first time this happened with you?
I got to participate in the Pluto mission, so that was my first mission, and this is a totally different type of mission, though. It's really like flying a different mission every phase. We're doing all sorts of different orbits and science for the next 2 years. So this is really day one of proximity operations at Bennu.
Well, thank you so much for talking to us. I'm really excited too. So now we're going to go over and we're going to meet Javi Serna. And Javi Serna.
So our entire team here at CosmoQuest is also part of the OSIRIS-REx team, and we were able to attend the launch, and we're super excited to see this happen too. So here we go. Okay, so tell me a bit about what you're doing right now.
So right now what I'm doing is I'm actually monitoring the transmitted signal from the OSIRIS-REx spacecraft. So what's happening is the DSN has transmitted a radio signal to the spacecraft. The spacecraft has then taken that signal, turned it back around, and it's received here on Earth. And what I'm looking at is a real-time measurement of that signal. And that gives us two things. It gives us a quick access into how well the comm system is performing, but additionally it also provides us with Doppler, which is the change in velocity of the spacecraft, which is crucial information that the navigation team uses to essentially assess how things are happening as we about to approach the burn.
Now you mentioned something called the DSN. That's the Deep Space Network.
The Deep Space Network. So it's a series of events kind of scattered, a series of antennas all across the Earth. And so basically we use those antennas to basically lock into the spacecraft and then receive the signal from the spacecraft back.
So what we're going to be looking for now, or very soon, is going to be a change in velocity.
A change in velocity, and you can see here I have the Doppler residual up, and so we're basically, as soon as the burn, we receive the signal here on Earth, we'll see a Doppler shift, which should tell us that the burn has started.
So how long have you been working here at Lockheed Martin?
I've been working here about 8 years and about 7.5 with the Deep Space Exploration Division.
So how are you feeling right now?
A little nervous. After this burn is completed, we're going to be approximately 7 kilometers away from Bennu at the closest approach. So it's exciting, a little intimidating. There's a lot of feelings going through me right now.
What are some of the things that you're going to do after this event? So when we go into proximity operations, does your job change a bit?
A lot of it stays the same, so it's kind of working in concert with navigation and kind of assess when Doppler is available, when ranging is available. Ranging is a measure of distance to the spacecraft, so we work closely with them to essentially keep providing that information to them so they can ultimately continue to build the ODs.
So how much time do we have now?
It looks like we have about 40 seconds or so before we start seeing the actual burn. And some other things that I look at is I'm looking at this graphics page, which kind of just quickly assessing the health and status of the components. So our transmitter and then our amplifier.
So just to remind you that we're live here at Lockheed Martin, and we are just about to arrive at the asteroid Bennu and begin proximity operations to study this asteroid, eventually returning a sample back to Earth.
Yeah, it's so exciting. I can't believe we're here. Like we're right there. All stations, stand by. Burn has started.
So they're looking at the radio telemetry. This isn't instantaneous. Everything is delayed by the amount of light travel
Stand by
time.
for Bennu arrival. So you can see here we have the Doppler residual, so we know the burn is occurring because I'm seeing that change in velocity from the spacecraft.
It's gotten very quiet in here. Everyone's whispering.
The Gulf voice is kind of hilarious because it's not like the spacecraft can hear him. But these are the things that happen when you're nervous and scared and know that the next several years of your life depend on the next 30 seconds. The average distance would be 0 because it goes in and out of our orbit.
You may have noticed we were doing a bit of an unusual high five there. That's called the tag five, because that's reminiscent of the tag SAM arm that's eventually going to retrieve a sample. So we're just going to sort of watch people enjoy themselves. We have arrived at the asteroid Bennu. The spacecraft has successfully done the engine burn to put us into proximity operations at this asteroid. The light travel time to the asteroid is currently about 7 minutes, which means the asteroid is somewhere on the order of, probably the high 80 million miles away. So
it's almost
it took us about 7 minutes to get the signal to confirm that that we have in fact arrived at Bennu. So now I'm standing here with Heather Enos, and Heather is the deputy principal investigator of the mission from the University of Arizona. So, okay, Heather, what are you feeling right now?
My heart rate is like 3 times faster than normal, but I'm super excited. I mean, watching the team celebrate such an amazing milestone honestly brings personal joy to me in so many ways I can't even explain. These guys are, and women, such an amazing team, and I'm so proud to be part of it.
I think a lot of people don't realize the amount of time needed to make a mission like this. How long have you been working on OSIRIS-REx?
So I've been working on this mission for nearly a decade. I started working on it in 2008, and that was the beginning of the design of the mission, and bringing together this amazing team to go through development and then eventually operations, launching in September 2016. And although today's our arrival, we've been doing a lot of things since we launched, and during our approach, exercising the team, our instruments, our spacecraft. So it's been a long time coming to the arrival, and we're really looking forward to the next chapter of this mission.
I always love moments like this. People think of science as being kind of dispassionate, logical, not very emotional, but you can sort of see the tension on people's faces, and then there's sort of this joy that erupts.
Yeah, no, I'm probably one of the more emotional ones on the team, because I take, it's a family, it's not just a team, and watching everybody grow every day really is very satisfying.
Okay. Right. Well, after that moment, we have a chance to actually talk a little bit about what's going on in your role in the mission. So, as the first thing that they're going to be doing is actually rolling a video, I believe, of images of Bennu as OSIRIS-REx comes up. So, what are we looking at in this video?
So, during our approach, we've been slowly creeping up to Bennu, and during that time, we've been taking the opportunity to snap images using the OCAM's camera suite that was built at the University of Arizona. So.
This is a carbonaceous chondrite. It's a regular, boring asteroid.
The surface, and it's given us an opportunity to really get a sneak peek at what we're about to embark on. So we're getting great images back. We can see the surface has got a lot of boulders, craters, a lot of diversity in the surface. So it's been really exciting.
So talk a bit about your role. So you are the deputy principal investigator. What is your role in the mission then?
So as the deputy principal investigator at the University of Arizona, OSIRIS-REx is a principal investigator-led mission out of the University of Arizona. And so what that means is we have the overall responsibility of ensuring that we meet all of our science requirements that we have agreed to with NASA, our stakeholder, and our partners, in addition to making sure that we stay within our resources that we've agreed to. My primary role during operations is to oversee the science planning and operations center as we're doing operations implementation, as well as we have the science processing center at the University of Arizona. So I oversee that on a pretty daily basis. I work really closely with our team to make sure we have our plans in place and that we have all of the people and resources necessary to get our jobs done.
Well, let's get to a couple questions people are actually sending in. So let's see, we have a question for Heather. Marcia Dunn from AP asks, also when the spacecraft was launched, Bennu was described as a roundish black asteroid, about 1,600 feet at its middle. Any updates, please, on your description of the asteroid now that you're up close and personal to it?
Yeah, so Bennu is a very exciting small body, and our science team did a really great job characterizing the asteroid prior to us selecting it. Bennu is considered one of the most characterized asteroids that we have. However, the data that we are collecting is really very indicative that the science team was very good at doing many good predictions in terms of its mass, its size, its albedo. And so we're getting confirmation that a lot of the assumptions were pretty close to accurate, but we also are getting images that we've never seen before that are giving us a lot of insight to potential sample size.
So to those of you who are asking if we're going to get images during this, we aren't. At this point, the spacecraft is automatically taking imagery as it goes. Imagery is being downlinked and mosaicked together. It is 7 light minutes away. I'm sure that once they have the images and they have processed them so that they're nice and shiny and pretty, then they will be sharing them out.
Many more images, our shape model, and hopefully.
I don't know what just happened other than they radically changed shows. I think what we just experienced is NASA TV is administered by Human Spaceflight, and the Science Mission Directorate had it on loan for their mission encounter, and we have now radically switched. Hey Guido. Okay, so let me switch over to host only since I don't. Yeah. Okay. So, hello everyone. My name is Dr. Pamela Gay, and you have been watching The Rendezvous. Thank you so much, Boatnik, for the subscription. For those of you well, I don't think you just joined. Some of you did. For those of you who don't know what you've been watching, this was the arrival of the OSIRIS-REx spacecraft at the little tiny rocky asteroid Bennu. This is a mission that launched back in 2016, and CosmoQuest is part of the OSIRIS-REx team. It's our software that is going to be helping the team find the rock they're going to retrieve and bring back to Earth. Now, one of the reasons that we're super excited to study rocks like this is it hasn't undergone wind. It hasn't been reprocessed through a volcano. It hasn't been rained on, hammered on, dealt with biological life. The rocks on Bennu are pretty much the way they were the day that world formed. They've been hit by UV light from the sun and high energy particles, but that's only going to affect the topmost bits of the surface. When we crack that rock open and look inside, the volatiles, the inclusions, everything mixed in that rock is a sample of the original materials, unprocessed and raw, that went into building our solar system. Now, asteroids do get rearranged over time. They sometimes get flung outwards, they sometimes get flung inwards, but sometimes they do get to stay exactly where they started. Bennu has an orbit that is very similar to the Earth's orbit. This is actually a bit of a problem. There is a tiny non-zero chance it will hit Earth in the next 100 years. It probably won't. And if it formed where it's located now, that means that the stuff it's made of is the same stuff our world is made of. So we just might be able to bring back, well, essentially the planetary equivalent of raw cookie dough batter. In this case, it will let us sample just what it was the Earth originally started out with. Now, I am here to answer your questions, and just throw them in the chat, and if you can @ me, that will make them easier to find. Yes, this is totally astrogeochemistry. It's kind of awesome. So I'm not seeing any questions, which is completely fine. So we're going to have a lot more going on today here at CosmoQuest. Starting in 45 minutes, actually more like 40 minutes at this point, we're going to go to our coverage of, well, today's news in space and astronomy. Directly following the Daily Space, our news show, we're going to be covering yet another spacecraft launch. So sometimes your Mondays just have to be full of space. So I'm seeing there's a question in the chat. What is the spectral makeup of Bennu from early scans? This is what we call a carbonaceous chondrite. This means that it is the most common kind of asteroid out there. It's boring and rocky and has carbon and is the kind of object that burns up and explodes when it's going through the atmosphere. If you remember back in, I believe it was February of 2014, actually no, it was earlier than that, February of 2013, there was an asteroid that exploded over the city of Chelyabinsk in Russia. That particular kind of exploding asteroid that was very similar to Bennu. It's a asteroid that crosses Earth's orbit and is made of boring carbonaceous minerals. Other questions out there? Well, we're not so much sampling it before it goes kaboom. We're sampling it because it's there and it's nearby, and it was easy to get a spacecraft there that will then be able to come back to Earth without a lot of changing of velocity being necessary. Now, it could go kaboom on our planet, and this one, unlike the one that hit Chelyabinsk, is big enough it would get through the atmosphere. This particular asteroid is about 500 meters in diameter. This makes it a little bit, well, if you set it down next to the Empire State Building, it would stand up a little bit taller. This means it's a city destroyer. If this particular asteroid was to hit our Earth, it would do significant damage. It's not a world destroyer, but yeah, it's a problem that we would need to know how to get rid of. So do we have any other questions out there? So as always, this channel is brought to you by the Planetary Science Institute, working in collaboration with Youngstown State University. We're waiting to hear what's going on. We know campus is under lockdown right now, with Annie locked in her office. So this is one of those times where I think thoughts and prayers are really the only thing we can do. So we're all sending Annie and everyone else locked in their offices at Youngstown all the best hopes that whatever is going on, there's currently no active shooter, but whatever goes on is going on, ends quickly with no one being hurt. So to learn more about Bennu and the OSIRIS-REx project, follow us on Twitter. We're going to be posting things on our blog as we learn them. So stay tuned. Any expectations on that sample? Well, it'll be a rock. One of the problems about having expectations is our universe over and over has proved that it's capable of doing things that are far more interesting, creative, and diverse than what we theorize it's going to do. So I don't want to lock us into any particular things other than saying the rock will be a rock. Yeah, finals time is always a bit scary. We had lots of things that happened at Michigan State. It was kind of standard during finals week, but the modern age is much scarier. So if you don't have any more questions, I'm going to shut down for about half an hour and prep for the daily space and try and fix, there's a background noise that's my space heater that I think I need to go kill. So come back in 30 minutes for the daily space, and we will be bringing you all that is new in space and astronomy. Thank you so much for joining us for our live coverage of the OSIRIS-REx arrival at Bennu. The mission is now working on acquiring images that will be mosaicked together, and we will be bringing you the science as quickly as we can and as fast as we know it, and we're going to invite you to be part of making that science happen. Thanks, and I'll see you on the other side. Bye-bye.